Okie dokie. So this is week 2, part 2, where we are dealing with some applications. So this is called modeling. Modeling is mathematical modeling. So I think I actually said this in a sentence, which is kind of cool. So modeling means using math to describe a situation and predict future outcomes. Predict the future? Yep, math can do it. So that's sort of how the interaction between math and science goes, and engineering is math is used to predict the future. So, basically students see these as word problems, and word problems are difficult, but here are some things to consider. Now this usually involves additional work, and so students are reluctant to actually do it, but sometimes this is what you got to do. So, steps are helpful hints. I give you draw a diagram, make a graph, or a table of values. I'm going to underline those. Diagram, graph, table of values. And in these questions, I tried to do those just for the sake of example to show you how that could possibly happen. We're going to identify variables, so what do you know and what do you want to know? Frequently, students will just read the question and then be like, I don't get it. I'm confused. The answer doesn't pop in your head. That's fine, but the question does tell you something, and the question does ask you something, and that you can interpret. So writing that down is helpful. How are the variables related? Writing an equation, this is typically the most difficult part right here, that translating the words into equation. Once you have the equation, using your math skills to solve it usually isn't that hard. So here is an example. Mr. Hensley rides 200 miles per week, for the sake of example. How long would it take him to ride to the moon, assuming that he could actually ride, through outer space or whatever? So there's some sidewalk that goes to the moon, and he's got oxygen tanks. How long would it take him to ride to the moon if he rides 200 miles per week? Oh, and we need, this information should have been there. The distance to the moon is 239,000 miles. I just forgot to write that in the question. Or maybe you knew that. So, if we were drawing a diagram, we might draw something like this. I'm a very visual learner, and this, to me, would just be helpful. We have a little bicyclist, and 200 miles per week, and here's the moon. And so, I have in my mind, okay, there's some bicyclists. You got 200 miles per week. I would also take this information here and say, all right, and the distance from the bicyclist to the moon is 239,000 miles. And just this right here would help me sort of interpret the situation or think it through. You could also make some graph. So we have distance and time. So here's 1 week. Right? We know that Mr. Hensley rides 200 miles in 1 week. So that's this data point right here. That's given to us. What we're interested in is the distance to the moon. So this right here. All right? So this is what we're looking for. This was given to us, and we have a graph. And so now you're thinking, equation of a line, or maybe proportions, or similar triangles. There are a number of ways that you could solve this. If you were to write out a table of values, this also might be helpful. So after 1 week, he's gone 200 miles. After 2 weeks, he's gone 400 miles. After 3 weeks, he's gone 600 miles, etc. And then after, again, this is what we're looking for, how many weeks, he's gone 239,000 miles. So you don't have to do any of these, but all three of those things would probably be helpful if you saw this question and you didn't know how to solve it. So this is definitely what I recommend you do. Well, I recommend you do all this, but this I'm actually going to require. So we write down the variables. 200 miles per week, this is given information. We call that the rate or speed. Velocity maybe. T is time. This is what we're solving for, or our unknown. And we were also given this information, the distance to the moon, 239,000 miles. So I don't see students doing this usually. Right? The students that get it are doing this, but if you're confused, it's easy to just look at the paper and not do this. But this will be helpful. Okay, so we have our variables, and then the difficult part is this, coming up with the equation, but you're probably familiar with the distance equals rate times time. And so if we just plug in, here's distance, here's rate, here's time, and You definitely have the algebra skills to solve that, and we get t equals 1,195 weeks. I divided by 52 just for the sake of interest, and 23 years. Okay, because this is a correct number, and that 200 miles per week. He probably rides more than that, but that's a good estimate of somebody who's out there riding their bike 200 miles per week. So 23 years, yeah, you'd need a lot of oxygen and food. I don't know, maybe it'd get boring. All right, next page. Okay, so the question says the sum of 4 consecutive integers is 30. So we have a couple of vocab words in there. We have sum, meaning we're adding, and consecutive, meaning one after the other. For example, 10, 11, 12, 13. Example. So consecutive, one right after the other. So we're supposed to write an equation and what are the integers. So here is me drawing a diagram. We got a number and a number and a number. And I don't know what they are, but I know that this is one more than this is one more than this, etc. I know that if I add them all up, so the total area is 30. And I don't know, if you're geometrically inclined, you might be doing a trapezoid, variables, area. This is probably most helpful in this situation. So here's a table of values. Here are the integers, 1, 2, 3, 4, 5, 6, and we can keep going. And so the sum, let's see, so the sum of the first 4, we have 1 plus 2 plus 3 plus 4, so the sum is 10. All right, and if 5 were our last number, we would be adding together 5, 4, 3, and 2, so that sum is 14. If 6, maybe I'll color code here, if 6 were our last integer, we'd be adding together 6, 5, 4, and 3, so 7, 12, so it would be 18. That doesn't look right. Let's see. That would be, yeah, that's right. Okay. And then you could keep going. And so do you see how the numbers are increasing? So somewhere out here we're going to say, oh, the sum is 30, and then you would just know it was those 4 numbers. So this would be sort of a guess and check type method, but looking at it like this will be helpful. Here is defining variables and stuff, so we're of course going to use some letter and say, okay, x is our unknown, and let's call that the first number. And you could say, all right, y is the second number, and w is the third number, but you really only want one variable. The more variables you have, the more difficult it is to solve. So x is the first number, x plus 1 is the second number, x plus 2 is the third, and x plus 3 is the fourth. These are consecutive. So what we know is that adding all these together equals 30. So our equation then, the challenging part usually, is translating it into this. We got first number, second number, third number, fourth number, add them all together. The sum is 30. And then we could go ahead and solve. Let's see. 1, 2, 3, we have 4x plus 6 equals 30. And so 24 looks like x is going to be equal to 6. All right. So we'd have 6. Let's get a different color here. I know this is a little messy. Sorry. So 6 was the first, 7, 8, and 9. If we add those together, what do we get? 13, 21, aha, 30. Okay, so these would be our numbers. And again, just sort of visual representations, diagram or chart, table, defining variables, all these things are very helpful. And, you know, for some of you, you're going to read the question, you're going to be able to write that out, and then go right to the answer. That's great. This will be very helpful for the rest of us. Okay, number 3, the rectangular classroom. We have a rectangular classroom. It's 10 feet wider than it is long. If the floor has an area of 704 square feet, what are the dimensions? So, diagram. Wide, long. And so I'm choosing x to be the length and x plus 10 to be the width. We could also, if we had said, let's say that the width is w, then the length wouldn't be L. I mean, it would be, but that's not helpful to us. But we could call it w minus 10, because we know that this is 10 less than this, because this is 10 more than this. So both of those situations would work. Let me get rid of that. There we go. Okay, and we know that the area, so this was basically drawing a diagram and defining the variables. We could maybe write that in there, but we know that length times width is going to give us 704, so we can jump right into equation. Area, length times width, so 704 is this. Distribute, recognize that we have a quadratic, so we need 0 on one side. I subtracted, and then factoring this, that might be a little challenging. I knew what the answer was. Let's see. Oh yeah. So I knew what the answer was. Watch this. And this gives us 1, the x is 22, and also the x is negative 33. This is sounding suspicious for a distance, but let's take a look at this. X equals 22 and see if that makes any sense. So if this is 22, then this would be 32, and if we multiply 32 by 22, we get 704. So it works. These would be the dimensions of the classroom in feet. Alright, and here, so this is where we're dealing with how long it takes to do a task or a job. And question 4 says, a certain homework assignment takes Joey 60 minutes and Josefina only 40 minutes. If they split the work, each doing part, how long will it take them to finish the assignment? So I know that some students sometimes do this. They're like, hey, you do the odds and I'll do the evens, right? And then we finish the homework in half the time and we just copy each other's answers, meaning we get only half the practice. So I don't recommend that. But for the sake of this question, let's see how we can figure this out. So this is how we start. The job or the task per time is the rate. So the rate at which Joey does the job, the homework assignment, he does 1 homework assignment per 60 minutes. Josefina does 1 homework assignment per 40 minutes. So this right here is the rate. And if we look at this equation, if we multiplied both sides by time, we could get that the job done, or one task, or one homework assignment, however we want to describe it, is equal to rate times time. So down here, and this is pretty helpful right here, if they're working together, we can say that one job, meaning completing the homework assignment, mowing the lawn, whatever it is equal to whatever Joey does plus whatever Josefina does. And so for Josefina, job is rate times time, and for Joey, the job done, the amount of the task done, is equal to rate times time. So do you see how we have 1, meaning 1 complete task, equals the rate times time for Joey plus the rate times time for Josefina. So setting it up like this, then we just use our fraction skills, 5 1/20ths t, multiply both sides by the reciprocal to solve for t, and again t would be in minutes, alright, and we end up with 120 over 5, 24 minutes. So does this answer make sense? If Joey takes 60 minutes to do it and Josefina takes 40 minutes, so if there were 2 Josefinas and they were working together, it would take 20 minutes, right? Because it's half the time. If there were 2 Joeys working together, it would take them 30 minutes. But because Josefina's faster, Joey's a little bit slower, it's going to be something between 20 and 30 minutes, so this 24 minutes makes perfect sense. Notice how it's not the average, it's not 25, it's close to that. Turns out that Josefina would do more than half the work. Shame on you, Joey.